Hello viewers, you are welcome to our series of lectures on complex numbers by Professor E.O. Efan. This is our second lecture in this series, and in this lecture we shall treat the following: 1. Equality of complex numbers. 2. Addition and subtraction of complex numbers. And 3. Multiplication and division of complex numbers. Let us begin with the equality of complex numbers. Given two complex numbers, z1 equals to x1 plus iy1 and z2 equal to x2 plus iy2, then z1 is equal to z2 implies that x1 is equal to x2 and y1 is equal to y2. That is, the real part must be equal and the imaginary part must also be equal before we consider two complex numbers to be equal. Example 1. Let z1 equal to 12 minus 3i and z2 equals to ab plus bi. Find a and b so that z1 is equal to z2. Solution. Equating the real part and also equating the imaginary part, we obtain the real part of z2 is ab and the real part of z1 is 12, so ab is equal to 12. The imaginary part of z2 is bi, while the imaginary part of z1 is minus 3i. So equating the two, that will give us b equals to minus 3. Then from the first equation, we make a the subject of formula to obtain a equals to 12 all over b. Substituting for b, we have 12 all over minus 3. 12 divided by minus 3 will give us minus 4. So a is minus 4 and b is minus 3. Now, addition and subtraction of complex numbers. Given two complex numbers, z1 equal to x1 plus iy1 and z2 equal to x2 plus iy2, then 1. z1 plus z2 is obtained by adding the real part and the imaginary part respectively together. That is, x1 plus iy1 plus x2 plus iy2 will give us x1 plus x2 plus iy1 plus iy2, and that will be x1 plus x2 plus I into y1 plus y2. 2. z1 minus z2 is equal to x1 plus iy1 minus x2 plus iy2. Again, we subtract the real part and we also subtract the imaginary part to obtain x1 minus x2 plus I into y1 minus y2. Let us take example on this. Example 2. If z1 equals to 5 minus 9i and z2 equals to 2 plus 6i, let us find the following: 1. z1 plus z2, 2. z1 minus z2, and 3. z1 plus bar z2. Solution. 1. z1 plus z2 is equal to, we add the real part, which is 5 plus 2. Then we also add the imaginary part, which is minus 9i plus 6i, to give us 5 plus 2 equal to 7, minus 9i plus 6i is minus 3i. So z1 plus z2 is equal to 7 minus 3i. 2. z1 minus z2, We subtract the real part, 5 minus 2. We also subtract the imaginary part, minus 9i minus 6i, to obtain 5 minus 2 is 3, minus 9i minus 6i is minus 15i. So z1 minus z2 is equal to 3 minus 15i. 3. z1 plus bar z2. Bar z2 is the conjugate of z2, which is 2 minus 6i. So we add the real part and we also subtract the imaginary part. The real part is 5 plus 2, while the imaginary part will be minus 9i minus 6i. So this will be equal to 5 plus 2, then minus 9i minus 6i. 5 plus 2 is 7, and minus 9i minus 6i is minus 15i. So z1 plus bar z2 is equal to 7 minus 15i. Multiplication of complex numbers. Again, given two complex numbers, z1 equals to x1 plus iy1 and z2 equals to x2 plus iy2, then 1. z1 times z2 is equal to x1 plus iy1 times x2 plus iy2. Let us open this bracket as follows. x1 times x2 will give us x1 x2. x1 times plus iy2 will give us plus ix1 y2. Now, plus iy1 times x2 is plus iy1 x2, plus iy1 times plus iy2 will give us plus I squared y1 y2. But I squared is minus 1, so this will be equal to x1 x2 minus y1 y2. That's put the real part together, plus also put the imaginary part together, which is I into x1 y2 plus y1 x2. 2. Let us multiply z1 by bar z1. This is equal to x1 plus iy1 times x1 minus iy1. Opening this bracket, we have x1 times x1 is x1 squared. x1 times minus iy1 will give us minus ix1 y1, plus iy1 times x1 will give us plus ix1 y1, then plus iy1 times minus iy1 will give us minus I squared y1 squared. Since I squared is minus 1, so this will be plus y1 squared. Then collecting the real part together, we'll have x1 squared plus y1 squared. Please note that minus ix1 y1 plus ix1 y1 will cancel out. So when you multiply a complex number by its conjugate, the result will be purely real. Example 3. Let z1 equals to 5 minus 3i and z2 equals to 9 plus 4i. Then 1. z1 times z2 is equal to 5 minus 3i times 9 plus 4i. Opening the bracket, we obtain 5 times 9 is 45. 5 times plus 4i is plus 20i. Minus 3i times 9 is minus 27i. Minus 3i times plus 4i will give us minus 12i squared. Recall I squared is minus 1, so minus 12 times minus 1 will be plus 12. Then collecting the real part together, we'll have 45 plus 12. Then 20i minus 27i will give us minus 7i. And this is equal to 57 minus 7i. 2. Let us multiply z1 by its conjugate. That is z1 times bar z1. This is equal to 5 minus 3i times bar z1 will be 5 plus 3i. Opening the bracket, we'll have 5 times 5 is 25. 5 times plus 3i is plus 15i. Minus 3i times 5 is minus 15i. Minus 3i times plus 3i is minus 9i squared. Again, I squared is minus 1, so minus 9 times minus 1 is plus 9. Then we'll add it to 25 to obtain 25 plus 9. 15i minus 15i will cancel. 25 plus 9 is equal to 24. Division of complex numbers. When dividing complex numbers, we multiply and divide by the conjugate of the denominator and then simplify. Example 4. Let us consider dividing 4 minus 7i by 2 minus 11i. This is equal to 4 minus 7i all over 2 minus 11i. The conjugate of this denominator is 2 plus 11i, so we multiply and divide by that conjugate. We multiply by 2 plus 11i, we again divide by 2 plus 11i. We can then multiply out the numerators and we also multiply out the denominators to obtain the following. 4 times 2 is 8. 4 times plus 11i is plus 44i. Minus 7i times 2 is minus 14i. Minus 7i times plus 11i is minus 77i squared. All over, let us multiply out the denominator. Please observe that the denominator is the difference of two squares. So it's simply 2 times 2, which is 4, minus 11i times 11i, that will give us minus 121i squared. I squared is minus 1, so times this, that will give us plus 121. So this is equal to, in the numerator, I squared is minus 1 times minus 77, that will give us plus 77. 77 plus 8, that is 85. 44i minus 14i, that will give us plus 30i. All over 4 plus 121, since I squared is minus 1. And that is 125. So dividing through, we have 85 over 125, which can be reduced to the lowest term to 17 all over 25, plus 30 over 125, reducing to the lowest term is 6 all over 25i. So 4 minus 7i over 2 minus 11i is equal to 17 over 25 plus 6 over 25i. We have come to the end of our second lecture in this series. Thank you for watching and keep on watching. I am your lecturer, Professor E.O. Efau.